Perched on the surface of a survivor, we survey the solar system. 60 million years have passed since solid matter first froze in the solar nebula, only 1.3% of Earth's history. Those first tiny particles of matter coalescing initially into dust, then mountain-sized planetesimals, and finally dozens of planetary embryos, doomed for a fight to the death. Now, after an explosive race for mass and dominance, only a handful of protoplanets remain. The surface of our protoplanet is a blasted and blazing wasteland, coated by dead oceans of magma fueled by the primal inferno of atomic decay, sustained for a time by the bruising rain of planetesimals. But these are mostly gone now too, absorbed by hungry worlds, or else ejected into the depths of the solar system and picked off by the leviathans lurking there. The table scraps of this primal feast fall regularly onto our protoplanet, one of its most successful feeders. On the surface are fractured heaps of fused and jagged debris, blasted apart by the incessant bombardment. A hazy atmosphere of carbon dioxide blankets the broken landscape. Moisture wets the dust. Somewhere on the surface, there may even be a new kind of ocean forming. We may even imagine that someday this scrappy champion will sprout another newcomer. Life. But we would be wrong. Our protoplanet is not Earth. Its name is Theia. Despite an impressive start, Theia is not destined to win this planetary competition, for another combatant lurks in its orbit. Over the horizon, another protoplanet careens into view. Theia's larger cousin, the Earth. Having experienced its own similar and short history, this young world is just moments away from its final act of formation. The burning sphere swells until it has eaten the sky. At last, with a deafening rumble, the two survivors crush into one another. Towering waves of material erupt and cascade into roiling chaos. Chunks of planet splash into orbit as the Earth devours its last meal. The ruptured planet consumes Theia whole as the energy of the impact melts solid rock into oceans of liquid magma yet again. In the sky, the blazing chaos gradually quiets and the process of accretion begins. This disk of debris will soon form the Earth's eternal companion, the Moon. This is Theia's gravestone. After nearby supernova sent shockwaves through our featureless cloud of gas and dust, after that cloud began to collapse, spinning ever faster as it shrank, spreading outwards as it spun, after the sun kindled into being at the centre of that shrinking, spinning, spreading cloud, the first two fragments of dust at the centre of our story crash into each other and stick together. Welcome to Earth. Our world begins as a scattering of dust particles so small gravity cannot even hold them together, static electricity instead sticking each piece to another. The disk around the sun is transforming from gas into dust, the clouds freezing into silicate crystals and complexes of calcium and aluminium, magnesium and iron. As they grow, they experience drag for the first time, the gas they were once part of now sapping their energy. The largest of these nebular snowflakes cascade from the outskirts, collecting at the disk's central plane. As our nascent Earth drifts towards the Sun, it is also falling in on itself. The more the snowflakes grow, the more energy is sapped by the passing nebula. Earth faces its most dangerous challenge. If it does not grow quickly, it will be captured by the gravity of the Sun and plummet into the furnace. Worse, as our clump of dust expands to the size of a pebble, the electrostatic forces feeding it cease to be effective. Yet neither can gravity bring new material to an object so small. Pebbles drift past each other unaffected. A fortunate few collide only to ricochet and drift apart, or worse, fragment and disperse. Growth has stalled. In the inner disk, vast throngs of meteors stream towards the Sun. Many are as large as a meter across and still struggling to grow. Most will not survive, but the Earth is truly lucky. It is located in a region of concentrated nebula that will collapse, mutually attracted by its cumulative mass. The Earth expands rapidly past the danger zone. Now it can set its own traps for its doomed cousins, siphoning off mass bound for the Sun. While the meteors plunge inward, the gas billows away. Radiation from the juvenile Sun pushes the vapors outward. The hydrogen and helium leave the Earth behind. Carbon leaves, water leaves, even potassium and sulfur leave, carried away by solar winds. The Earth will not see these elements again for millions of years. As the Earth grows into a planetesimal many kilometers in diameter, it begins to melt. The closest material has always been scorched by the Sun, but this heat doesn't originate from the heart of the nebula, but from the matter of the nebula itself. Radioactive decay, the raw fire of nuclei tortured into unstable monstrosities. Now concentrated on the proto-Earth, they are self-immolating en masse. Aluminium-26, a demon born alongside the nebula, has a half-life of only 730,000 years. The energy of its destruction melts the interior of the Earth, separating the heavy metallic iron from the lighter elements. It sinks to the center of the planetesimal and gloms together. For the first time, Earth has a core. But the Earth is not alone. While a tremendous volume of material has plunged into the Sun, a multitude of other planetesimals careen through its neighborhood, and more are forming all the time. These bodies now commence a battle for survival and for a place in the solar system. Mostly molten mountains of material roam the disk for their prey. These gladiators destroy any lesser body drawn in by their gravitational pull. When two equally matched combatants cross paths, they fling each other wildly into new orbits. At first, chaos rules over the arena. With such spoils readily available, the largest planetesimals grow exponentially. But once the frontrunners of this battle royale have established themselves, a tense truce settles in. Each combatant carves out a zone of influence, an uncontested orbit, where it can systematically finish off every other opponent. The Earth emerges as one of these champions, settling down to a comfy snack. But in this solar system, there is always a bigger fish. Jupiter advances from the outer regions. Formed by the frozen volatiles once ejected from the inner disk, the primordial Jupiter edges ever closer. Planetesimals ensnared by the behemoth share two fates. They are devoured by this icy titan, or fatally flung from the solar system into oblivion. and with each doomed body launched outwards, Jupiter lurches inwards, within reach of more victims. Jupiter rampages through a hapless crowd of fleeing and flying planetesimals ever closer to the unformed, vulnerable Earth. At just 1.5 times the distance from the Earth to the Sun, Jupiter's attention is snatched by another colossal beast, Saturn. Locked in gravitational combat, these two monsters heave and shove each other, dragging themselves ultimately back into the depths of the outer disk. Left behind is a depopulated wasteland. The only planet that will form in this vast region is the comparatively tiny Mars. Starved of material, Mars is mostly complete after the first few million years. Safe in the inner disk, the future planets of Mercury and Venus are forming, as is Earth perched on the edge of no man's land. The luckiest survivor. Only a couple of million years have passed since the creation of the solar nebula, and much has changed. The gas has drifted away, the nuclear inferno has calmed, Jupiter has come and gone. Already most of the mass in the inner disk is concentrated in dozens of planetary embryos, 1 to 10% of the mass of the modern Earth. Among them are the adolescent Mercury, Venus, Mars, Earth and Theia, as well as many other contenders. It will take many tens of millions more years to decide the ultimate winners. While Jupiter lays waste to the edge of the inner disk, the Sun wreaks havoc near its center. 50 kilometers from the Sun, her children whip around at incredible speeds. Collisions here are catastrophic. When protoplanets clash, it is rarely clean. Instead, they rip into each other, spraying their insides across the void and part again, circling, then clash again on the next orbit and the next. Finally, the two bodies will collapse into each other. When Proto-Mercury encounters another embryo, they impact with such ferocity their mantles vaporize. Jets of gaseous planets spout away from the roiling cores, leaving Mercury much reduced in mass and enriched in iron. With so many gladiators and such erratic sparring, the ultimate victors will be chosen by chance. As this happens, glimpses of future Earth appear. The firestorm of radioactivity has died away, but the oceans of magma it created still burble beneath the surface. As the oceans slowly solidify, the materials of the Earth organize themselves. Iron sinks to the core, along with nickel and other heavy elements that bond with iron. Crystals precipitate in the swirling molten matter. Most shower onto the core and amass in dunes thousands of kilometers thick. The lightest elements and the most unreactive seep upwards and outwards and freeze near the surface. The Earth forms layers. Asteroids explode through the whisper-thin atmosphere and blast the solid surface into dust. It accumulates into drifts until a direct impact fuses the matter into solid stone once again. Great vents breach the surface and molten mantle leaks through. Seas of magma puddle and solidify. But this cohesion is short-lived. Armageddon returns to Earth each time it devours a defeated foe. Surfaces vaporize, mantles slosh, and a new surface congeals. Earth starts again. Water and the other volatiles reappear after tens of millions of years absent. Asteroids, planetesimals, possibly even ice rains down upon our protoplanet. Now with something to cling to, the carbon, ice and gases that were driven away by the heat of the sun have begun to repopulate the Earth's surface. After 60 million years of halting growth and abortive evolution, the Earth has nearly reached its final mass. Only one more collision, one more victim separates Earth from the end of its origin story and the beginning of its history. Thayer's orbit intersects that of Earth. By their combined gravity, they turn towards each other and lean into the blow. The impact is devastating. Crushed between the two planets, solid rock atomizes. Shockwaves liquefy the mantle. Fragments of the Earth buried thousands of kilometers deep are ejected into space. The planet staggers on its axis as it crumples back into a sphere. Oceans of hellfire tumble onto the surface. Superheated gas and droplets of magma suffocate the Earth. The extremities of this lunar disk rapidly coalesce into a hellish sphere that dwarfs even the Sun. Over the next 150 years, the cloud of dust billows outward. Little moonlets coagulate and spin off to join the moon. It is a replica of the Earth's formation, replayed in miniature. This is the last altercation Earth has with another protoplanet. Asteroids and planetesimals continue falling to Earth and the Moon for hundreds of millions more years. But another impact of this magnitude would have left scars on the Moon, if not obliterate it entirely. Thayer's destruction is unique only in that it came last. Many other upstarts met similar fates at the hands of the Earth. It's probable that several different moons grace the sky around our planet before our moon formed. It is a sign of the changing times that this companion sticks around. The Earth is done growing, but it is far from complete. Our planet is not a blue marble, but red and black and broken. After 60 million years, Earth has only begun its journey, a journey that will change it from the edge of the atmosphere to its very core.